Welcome Calculus AB. This is 2.5 Implicit Differentiation. The essential question is compare and contrast implicit and explicit. Let's begin. So two different vocab words, explicit form and implicit form. Explicit form you're familiar with, you just might not be familiar with this word, but it's where you have like y equals something. So y equals 3x squared minus 5. So the y is a function of x. So this form is just a variable, usually y equals. Implicit form is where we mix up the variables, the x and y. So x times y equals 1 is implicit. It's not in y equals form. But the function is implied to exist. In this form explicit, it does exist. Y equals whatever. So we actually can derive implicit functions. We've derived explicit functions before, always in y equals, but we can do it for implicit. Sometimes to just derive an explicit function, you can just rearrange it to an explicit. So for x times y equals 1, I can divide both sides by x, and what you'll get is y equals 1 over x, which x is negative 1, but you can differentiate that, and what you'll get is it becomes negative 1 over x squared. That worked out, but sometimes it doesn't. For example, this example down here, the x's and y's, we can't isolate the y variable, so we can't just rearrange it. We're going to need to do something else. And this is where implicit differentiation comes in. So I want to differentiate these functions right here with respect to x. And you're going to see this notation, d of dx. And this is, we've used other notations for derivatives before, but this is what we need for implicit differentiation. So d of dx, the derivative of x cubed. Notice that these two variables right here are the same variable. If they're the same, we can just straight up differentiate that, and that becomes 3x squared. Now, in example B, the derivative d dx of y cubed, x and y are different variables. They don't match. So you treat it kind of like the chain rule. The derivative is going to be 3y squared, but then times the derivative of y, which we're going to represent as dy dx. So it's basically the chain rule right there. Let's do part C. So it's x plus 3y. You can break that up of d of dx of x plus d of dx of 3y. You can differentiate the x, you know that's going to equal 1. But since the x's and y's don't match up, derivative of 3y is going to be 3 times dy dx. All right, now part D, this is going to be using the product rule. So my first part, I'm going to call the x the f and the y squared the g. That means my f prime is going to be 1. My g prime, we're still with respect to x, so it's going to be 2y dy dx. Now differentiating that, or using the product rule, I'm going to do the work up here. And I get f prime, so 1, times regular g, so y squared, plus regular f, x, times g prime, 2y dy dx. And I'm going to clean that up and write it as y squared plus 2xy dy dx. Usually put that dy dx at the end. And that's your answer. All right, let's try some others. So before we do that, let's talk about guidelines for implicit differentiation. You want to differentiate both sides with respect to x. That's like doing the d of dx thing. And then you want to collect all terms involving dx on the left. So move dy dx's to the left side. Move everything else to the right side. So kind of like with quadratic formula, you put numbers and variables to the left and 0 on the right, in a way. Then you want to factor out that dy dx and actually solve for dy dx. So your final answer is dy dx equals whatever. That's what we're gunning for. So let's try an example like that. So I'll find dy dx given this equation right here. So differentiating each of these, the first one, y cubed, is going to end up being 3y squared dy dx plus 2y dy dx minus 5 times dy dx. And since this is x, it's just going to be minus 2x, derivative of x, equals derivative of a number is still 0. Now, let's move certain things over. This x, negative 2x, has to be moved over to the right side. So I'm going to add 2x to both sides. And what you're going to get is 3y squared dy dx plus 2y dy dx minus 5 times dy dx equals 2x. All right, And that next step, I want to factor out. So I'm going to factor out the dy dx. That leaves me with 3y squared plus 2y minus 5 equals 2x. And to isolate the dy dx, you divide by this trinomial, 3y squared plus 2y minus 5, and your best final answer is going to be dy dx equals 2x divided by 3y squared plus 2y minus 5. And that's how you do that. Now, I'm going to skip this and do this in class. Now, I want to find the slope of a graph implicitly. So I want to determine the slope of the tangent line of the graph of right here at this point. And we don't have the figure. We don't need to look at it. It's in the book. So what I'm going to do first is I got to differentiate this function right here and find the dy dx. And then what I'm going to do for that is I'm going to plug in a value. And actually, you do need to solve for dy dx. This is basically your slope m. Or that's your derivative, and we got to find the specific value. So I wouldn't say that's your m. But that's what we have to solve for. So differentiating this, I'm going to say x squared differentiates 2x plus 4y squared. So it's going to be plus 4y. That'll be 8y dy dx is going to equal 0. I want to rearrange it to dy dx, so I'm going to subtract 2x on both sides. These will cancel out, so you get 8y dy dx equals negative 2x. And I want to divide by 8y on both sides, because I've got to isolate the dy dx. And these will cancel out, so you're left with dy dx equals, and reducing the 2 and the 8 to 4 and 1, so I'm left with negative x over 4y. Perfect. So there's my function, but I have to find a specific point. So at that specific point, I'm just going to plug in my x and y values. So that's going to be negative square root of 2 over 4 times negative 1 over square root of 2. Okay, now let's clean up this a little bit. And there's a bunch of different ways you could do this. But I know I'm going to have negative square root of 2 over negative 4 square root of 2. Or another way to say this, I know the negatives are going to cancel out. Another way to say this is going to be square root of 2 times the reciprocal, square root of 2 over 4. And that becomes square root of 4 over 4, which is 2 over 4. And I'm covering this up with my face, which is 2 over 4, which is going to end up being 1/2. So again, when you're dividing by fractions, I like multiplying by the reciprocal. There's a lot of different ways you could have done that. Your choice. 1/2. Let's try another one. Determine the slope of the graph right here at this point. So, first thing, I want to differentiate both sides of the equation. So you get a d of dx of both sides, right? So differentiating the left side, and this is going to require the chain rule. It's going to be 6 times, x squared plus y squared, and then times differentiating the inside. So it'll be, of x squared is going to be 2x, plus y squared will be 2y dy dx. All right? Times, or that's going to equal 100 times the product rule right here. So this is going to need the product rule, splitting the x and y. So it'll be 100 times the product rule. So this is my f and g. My f prime equals 1, and g prime is going to equal just dy dx. So it'll be 1 time f prime, 1 times g, so that'll be just y. Let's write that nicer. Be just y plus regular f x times g prime, so plus x times dy dx. Okay, and I have to rearrange this. This is where it gets fun, right? So distributing that 100, I get 100y plus 100x dy dx. And distributing this mess over here, which is also fun, I'm going to actually factor this 2 right here, 2x and 2y. You can pull out a 2 from both of those, and times the 6 will be 12. And that's going to be 12. Let's see. instead of doing it that way, I'm going to do it my way. I can follow the book, but I don't want to. I'm going to just FOIL this in here. So I'm going to get 2x cubed plus 2x squared y dy dx plus 2xy squared, y squared times this, plus 2y cubed dy dx. All of that times 6. All right. So distribute that 6. I'm going to get 12x cubed plus 12x squared y dy dx plus 12xy squared plus 12y cubed dy dx. This is a lot of work. That's okay. Equals the same thing on this side. So 100y plus 100x dy dx. Now I'm going to rearrange terms, and I'm going to kind of skip some of the work in here. But I'm going to, the dy dx terms are going to come over here. So this is going to be negative 100x dy dx. This term is going to stay plus 12x squared y dy dx. And this term is going to stay plus 12y cubed dy dx equals 100y. And then this is going to be subtracted minus 12x cubed. And this will be subtracted minus 12xy squared. All right. Now we get a factor. Fun. So we get a factor of this on the left. You get a dy dx equals 100x, negative 100x, plus 12x squared y, plus 12y cubed, equals the same thing. And then the last step here, I'm going to say dy dx equals, it's going to be 100y minus 12x cubed minus 12xy squared over negative 100x plus 12x squared y plus 12y cubed. Yeah, there's a lot going on there, but there's your answer. Luckily, we just plug in this point, x is 3, y is 1. And we've got to figure out the slope of the graph. So so our point is 3, 1, just as a reminder to myself. Plugging this in, we get 100 times 3, 100 times equals 100 times 1 minus 12 times 3 cubed minus 12 times 3 times 1 squared all over negative 100 times 3 plus 12 times 3 squared times 1 plus 12 times 1 cubed. All right, a lot of work here, right? A lot of fun. That's 100. 3 cubes, 27. 27 times 12 is going to be 27 times 12. This is a long video. Long day. 324 minus 12 times 3 is going to be 36. All over negative 300 plus 12 times 9 is going to be 108. Yeah, I know math. Plus 12 times 1 cubed, so plus 12. And doing all that work, so I get 100 minus 324 minus 36. And that's going to be negative 260. And I'm going to divide that by negative 300 plus 108 plus 12. And that's going to be 13/9 when it reduces. Trust me, that's the right answer. You know what? We'll stop it there.